So, welcome everybody. Good evening. This is Business and Economic Statistics 2. We in week 2 and module 2 of this class, done recording on. So as to record the class for those who are not present, and I am very glad that some of us are here, and so that's good. So at least I will not lecture to an empty space. So this is the second module, and we'll be talking about inferential statistics proper. Last week, we just introduced the concept of statistics, and we went through descriptive statistics. There was a homework assignment, which I think was not done quite well. So today I'm going to begin from that homework assignment and show what needs to be done. And this is because for the rest of the semester, we are going to have to present our summaries in exactly the way I had expected for them to be presented in that first homework assignment, because when you do inferential statistics, you begin, first of all, with a statistical summary in a descriptive form. And so you begin with descriptive statistics, and then from there you go to inferential, because the information that you're going to use for inferential analysis comes from a descriptive summary. So let's see how we proceed. I'm going to, like I said, bring up the previous homework and show how we were supposed to have done it. Okay, so I'm going to share screen. I'm going to share screen and show exactly what we were supposed to do. Okay, last week, are you seeing my screen?
Yes.
Right. Last week, I illustrated how to calculate average for a set of statistical data. Okay, average age of houses. Okay, and I illustrated the how to calculate the average age. And then the next question I asked was, would you consider that the average price of houses is the same in all three neighborhoods? Would you conclude that the average price per square foot of houses is the same in all three neighborhoods? Well, what I had expected that the class would do would be to use my example where I calculated the average age to also calculate the average price per square foot and also the average price. So let me go through then what I expected to see. And essentially, when I provide an example, like I did at that time, then you're supposed to extrapolate that example. I'm not going to do the entire homework assignment for you, but I expect you to extrapolate my example to other questions as much as you can. All right. So we have information here on the average age of houses per neighborhood. And we have three neighborhoods. Neighborhood 1, which is Harbor. And then we have neighborhood 2, which is Westcott, and neighborhood 3, which is West Lair. So I'm going to go through that and just show you what the table should have looked like. Because I really deducted a lot of points for simply not doing the problem. Okay. Okay. So here, look at average age. Okay. And average price per square foot. And I'm going to calculate average price. The problem is not difficult at all. So you just needed a table that had all three averages. So this is equal average for neighborhood 1, average age, and so you go down. Okay, so this is average age. This is a regular number. This is not about dollars. All right. And then for this equals average, and you go to neighborhood 2. We're still looking at age. This neighborhood, I'm sorry, neighborhood 2. Right? Regular number, dollars. Okay. And then for 3, was average. And you go to under age for neighborhood 3. Oh, why did somebody put this in dollars? No wonder. Okay. This should not be in dollars. I don't know why it is so. All right. So you see, I calculate average age. So average price per square foot. So you go down to average price per square foot. And so you do the same. Average for neighborhood 1, price per square foot. Okay. And for neighborhood 2, price per square foot. Right? For neighborhood 3 equals, be patient. This is a class of patients. Price per square foot for neighborhood 3. All right. So that's the last one, average price. Average price is in column A. Average. Neighborhood 1. Most average for neighborhood 2. Neighborhood 2 starts here. And for neighborhood 3, of course, average. Neighborhood 3 starts here. All right, so you see here I have a table that has all the averages, and the best way to present your results is to cut and paste your results in MS Word. So I didn't make that explicit. I'll do so for other problems. Okay, and so you can now format things here. And then the next question I asked was, do you think the average price per square foot is the same in all 3 neighborhoods? You can now look at this data. At this level, at this stage of our study, we are not yet doing inferential statistics. We were still doing descriptive, which is just a summary. And you look at the data and you say, well, at least intuitively, I'm looking at this data. The average price per square foot in one neighborhood is $298, and another neighborhood is $319, and the other neighborhood is $194. I don't think that the average price per square foot is the same in all neighborhoods. Maybe between Harbor and Westlair, the average price per square foot might be the same, okay? But when you look at the average age, again, maybe between Harbor and Westcott, the average age might be the same, but there's a big difference between Westlair and the other 2 neighborhoods. You can say the same thing for average price. You can say, well, it looks like the average price in the neighborhoods seem to be quite different. One is 405, the other is 456, which is far away from 405. And another one is 371, which is even way below. And so I don't think that the average prices in the neighborhoods are the same. I don't think, because all you can do at this stage is think, okay? So this is what I expected the class to do, which is to cut and paste these results in MS Word, but at least to calculate the average for all 3 neighborhoods. You don't have to cut and paste in MS Word if I didn't ask you to, but at least to look at these results the way they are and give the results an interpretation. So I expect this next time where you actually take the steps to do the work. Okay, some students just showed me this raw data, that is, they printed out this raw data and tried to make a statement. It doesn't mean anything. This is why we said, why we define statistics to be the collection and analysis of unorganized mass data. Okay, this is a whole lot of data. What if you had a whole sea of data like 10,000 data points, observations, or 10,000 houses? How could you make any statement just by looking at that sea of numbers? No, you cannot do that. So you have to summarize collection and analysis of. And what does analysis involve? Analysis involves reducing the data to some kind of numbers or in such a way that you can take, you can glance at it and be able to make some general statement. Okay, having said that, I'm going to now go to the next step, okay? I'm going to go to the next step, which is to discuss inferential statistics.
Agni?
Yes.
Yes, I was looking at the assignment for this week, and
Mhm.
it's like you have to find the standard deviation of the average price age of houses in the two neighborhoods, and you have to find the standard deviation of the average price for per square foot. Can you go over that, like how a
Yes, that is
person?
exactly what I'm going to do. Okay.
Okay,
And
okay,
the reason that I went through this is I don't want to see the same kinds of thing I saw the last time. I'm going to do one of them. And so your job is to do the rest.
okay.
Okay. Okay.
Mhm.
I'm going to do one of them as an illustration, and then your job is to do the rest. And I'm going to also go through the example of confidence intervals and how to do them. All right.
Yes.
Okay. Just I'm hoping for my screen to settle down, and it is not. Uh, are you still seeing my screen?
Yes, I can see your screen.
Okay.
It's
But
not
yeah,
anymore though. It got your picture up.
yeah, but you're no longer seeing the Excel table.
No.
Okay. Now, the homework assignment for this um, week, I'm going to just give me a second. Let me pull it up. Okay. And so we're going to go step by step. We're going to go step by step. Okay, I'm going to share screen once more so that we can look at the problem. And then I'm going to pull up it says using the SPSS or MS Excel or Minitab processor, so you can use MS Excel, calculate the average price per square foot for houses in the two neighborhoods, the standard deviation of the average price per square foot. I also said average age of houses in the two neighborhoods and the standard deviation of average age. So I'm going to do one of them, and your job is to do the other one. Okay.
Okay.
Okay. So I'm going to take average price per square foot. Okay. So I'm going to stop share this one, and I'm going to pull up the data for it looks like something happened, something took away the information. All right. Are you able to see my screen?
Yeah.
Okay.
Yeah.
Okay. So here in this data set, it says calculate the average price per square foot. Okay. And I'm going to take that out. Just going to see if somebody. All right. You can see there are two neighborhoods. I said in the two neighborhoods. The neighborhoods are already sorted. So you have the neighborhood Rocher, which has a code 28. Okay. And then the neighborhood Borough Park, okay, which has a code 29. So we don't have to go through that anymore. And then it says calculate average age. Again, the average age is given to you here, date sold. Okay. We don't need to be going through that. This is one of those creative things that when you go to work, somebody's going to test you and try to find out what you're able to do, what kind of initiative you're able to take. And so I'm going to actually take off that data as a duplicate. Okay, so I'm going to take age here. Okay, what is the age of a house? What is the age of the house? Of course, the age of the house is the time that you're looking at the house, and you subtract the year that it was built. That is how you know the age of the house. Okay. Let me tell you a story as we are doing this class, and it's a story about life. Okay. Story about success. You should care about it. Okay. But after you care about it, I'm not saying you should kill yourself for it. You can only do what you're capable of doing. Everybody has an endowment. But if you really put in some effort, you will be able to do a whole lot more than you can do just doing nothing. Okay. It was Edison, the person that discovered electricity, I believe, who said that he never thought he failed in anything. He only thought that he didn't succeed. Each time that he tried and he did not succeed, he would have learned a lesson. Okay, he would have learned a lesson. And the lesson he learned was the lesson about what works and what doesn't work. And so at the end of the day, becoming a genius, according to Thomas Edison, is 99% perspiration and 1% inspiration. And I would say he's right. Maybe it is 75% or 60% perspiration and 40% inspiration. We are all naturally endowed. I can try all I want to be a nuclear physicist, but I will never succeed. So inspiration and natural endowment is important. But what if I never went to school at all? Then I'll never be a nuclear physicist, whatever my potential for it. That's very important. So effort is very, very important. Then the other story that I'm going to tell you is a story that I was told. Our professor told us that story when I was in the business school and I was a sophomore. And the story that the professor said to us was that there was a power outage. There was a power shortage in a small town in the 1930s. 1930s is long ago, many years ago. It's 90 years ago. He said there was a power outage. Nobody had electricity in town. And so after 4 days, the mayor was about to lose his job. The guys in the electric company were about to lose their license. So the managers called a retired engineer out from the mothball and said, please help us because we are totally lost and we're about to lose our jobs. And so the retired engineer came and he said, okay, turn on the switches, and he listened to all the click, 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 but no power coming up. He said, okay, turn off the switches again. And they did. He said, turn on the switches again. And they did. And he listened to all the clicks, He said, okay, everybody come with me. So everybody went with him to one corner of the grid, and he said, this little knot that is here, can somebody tighten it for me? And somebody tightened that knot for him. And he said, okay, everybody back up and switch again. And all the power came back in the whole time. Wow. So my God, you saved our lives and our necks and our jobs. So how much is your money for this work? He said $5,000. $5,000. Well, in those days, in the 1930s, you could actually buy 10 cars with $5,000. So you want us to give you the equivalent of 10 cars for knocking on that little spot. You have to give us an itemized bill so we can show it to the board of directors to explain all the things that you did for $5,000 for 10 automobiles. He said, no problem. I did your job. You're going to give me my $5,000. I will itemize my bill for you. So he said, for knocking on that little spot, $1. For knowing where to knock, $4,999. I hope you get the moral of that gist. I hope you get the moral of the gist. And so here is creativity. I gave you this problem. I didn't give you age. But the information for age is there. The house was sold in 2009. The house was built in 1970. You calculate the age for yourself. So it was B2, which is where you have the date sold minus G2, the year the house was built. So you drag it down. And so you have all the information that you need. All right. All right. So now you have age. And we have two neighborhoods. Okay, the two neighborhoods are Rocher and Borough Park. Okay. And so you have age. So average age. Okay. And you have asked you to calculate also average price or average something else, price per square foot. But I'm going to do only the average age, and I'm going to do standard deviation of age. Okay. And so average age is equals average so we drag it down for Rocher. For Borough Park equals average. Borough Park starts here. Right. All right. So we have average age. Now, how do you calculate standard deviation? Okay. How do you calculate standard deviation? I'm going to save this. And we know how to calculate standard deviation. The formula, I'm going to stop share. And we know the formula for standard deviation. Okay. So let us see if we remember that formula. Let's see if we remember the formula for standard deviation. I'm going to put a new slide here. Okay. We know the formula for standard deviation. So let's see if we still remember the formula is summation. Okay. X minus.
You can't see your screen.
Oh, sorry.
That's okay.
Thank you very much for pointing that out. I'm going to share screen. Okay. So you see my screen now?
Yes.
So we get the formula for standard deviation. Okay. See if I can. Okay. It's a different thing. Okay. Formula is okay. Minus X bar and here I'm going to redo this. Two. This works. Okay. This is not working. Okay, this is x bar squared, and I need to -1. This should be an x bar. Yeah. Okay, let's see how that's gonna work. Okay. And this should be an x bar here, but this is the formula that you're going to use. In any event, I'm going to do it using Excel. So I'm going to pull up the Excel file again. And the standard deviation, we're going to use the formula for standard deviation from Excel. Okay. But the formula for standard deviation is in your PowerPoint slides. If you want to refresh on it, I'm going to post the PowerPoint slide. But you go equals, okay. Standard deviation, you can see STDEF S, that is the sample standard deviation. So you use that, STD. S, and you go for the first and go all the way. Okay. So you calculate standard deviation. Okay. And you do the same. Equals STDEV S. And you go from for 29, starts from there, and you go to the end. Right. I'm still going to pull up the standard deviation formula for you, so you can discard whatever we were trying to do there. I just didn't have the time to do it right. And so you do the same for the other neighborhood. Don't just pick up what I have here in this neighborhood and copy it down for me, because you copy it down, and if I don't see the formula, I'm going to grade you down. And I'm trying to do this because I need to really motivate you to do what you have to do to become proficient, so that when you graduate, you have a degree that enables you to demonstrate that you have a degree. So you calculate the mean and the standard deviation. Now, one thing that I always see students do, and I tell students, you cannot do this. If I ask you to do a chart, do not plot average and standard deviation on the same chart. There are two different kinds of measures, okay? All right, so now that you have the average and the standard deviation, what next do you do with it? This is where inferential statistics comes in, okay? Now, in coming into this class, the assumption is that you have already done principles of statistics, and therefore you know how to calculate mean, you know how to calculate standard deviation, and so we don't have to spend too much time on it, okay? Let me see if just give me 1 minute. Let me see what's available here. Okay, I have to pull up a slide that shows you the calculation of standard deviation. I think you should have seen that in the first week's lecture. Okay, so I'm going to go back to it. But for this assignment, all you have to do is to use Excel, the Excel software to do it. You don't have to bother yourself doing it by hand. Okay, but in many places where you go, someone is going to find out, someone is going to try to find out if you even have an idea how it comes about. And that is something that you need to remember. All right. Okay, so I'm going to share screen once more. Hello?
Yes.
Hello?
Professor.
Yeah, we hear you.
Okay, well, my screen went blank.
Oh.
It cut off. Okay, so here is the formula for standard deviation. Okay. This is the basic formula. I was trying to do it myself. Just trying to put it up on the screen is quite a hassle. Okay, in any event, this is what it is. Okay. If you want to do it by hand, and you should really learn how to do it by hand. Okay. Having said that, so the next question, after you calculate the mean and the standard deviation, if you think about the homework assignment, which I'm going to pull up again. It says, for each neighborhood, establish a 98% confidence interval. Okay. Well, the lectures that you have in chapter 7 and in chapter 9 of the book require, teach you how to do a confidence interval. But let's go through it again. Let us go through it again. Okay. The confidence interval is the very first step in doing inferential statistics. Okay. And so if we have to spend a whole lecture on this, I will. Because this whole class, you can see we have gone from descriptive statistics to inferential statistics in 1 week. In your introductory statistics class, you went from descriptive to inferential. It took about 5 weeks. but it's assumed that you already know. But I don't like to make these assumptions. By now you may have forgotten certain things. So the first thing that I'm going to do is to define what do we mean by inferential statistics. So before I even get there, I'm going to put up a new slide here. And so that I'm going to extend this homework assignment by another week to make sure that we learn this. Inferential statistics. Okay. What is it? Inferential statistics is to use information from sample.
Are you typing something? I can't see what you're typing.
Yeah, it's in the other screen.
Are you seeing my screen share?
It's in the SPSS one you were doing the homework. You're not seeing the other one that you're doing now.
Okay, let me stop share. Let me share again. I am glad you're pointing these things out. Are you seeing the screen with inferential statistics on it now?
Yes.
Okay. So what is inferential statistics? Inferential statistics is where you use information from sample, make judgments about population. So last time we defined sample and we defined population. We explained why we use sample information to make statements about population. Okay? Population is when you count every member of the group. Okay? When you take the data from every member, suppose you talk about the population average age. You take every single registered student at Evers College and ask their age, and they give you their age, or you find out their age, and you use that data to calculate the average age. What you have is the population average age. But suppose you encounter 50 students in the street who are Evers College students who are registered in Evers College, and you ask them their age. And so that 50 students that you encounter randomly for some, one way or another is the sample. Okay, so sample is selection from the population. And so why do we rely on sample to make judgment about the population? Because sometimes the population is difficult to define. Sometimes it's time consuming to get information from the population. Sometimes time constraints prevent you from getting all the information from the population. And sometimes it can be very costly to get information from the population. And so you use information from a sample. Okay? So now the first step in inferential statistics is to estimate confidence interval. Okay. Then the next thing we do is hypothesis testing. Okay, and what you do then is you take data from sample, you calculate average, calculate standard deviation, okay, and then you determine, okay, margin, okay, and so then that leads you to select you say level of confidence. Okay, so this is the first step, confidence interval. Okay, and so the process involves then to calculate average, to calculate standard deviation, and to determine the error margin. And so the next thing I'm going to ask then is, what are the tools? Okay. First of all, you have to then determine the, let me say, probability distribution. I'm going to make this very simple. Okay. For example, you can use a normal distribution. Okay. You can use a chi-square. Distribution. You have to determine the kind of, distribution we're going to use. For this class, we're going to use normal distribution. We're going to use normal distribution. Normal distribution is a member of the class, member of the class, not a class, a class of continuous probability distribution. Okay. Okay. It's a member of the class of continuous probability distributions. And that is what I'm going to move into next. First of all, you must determine what kind of probability distribution you're going to use. And you can use chi-square distribution, you can use F distribution. There are different kinds of distributions you can use. I'm just talking about the very simple ones. F distribution, yes, we will get to F distribution in this class, okay, to do a hypothesis test, okay. We may not get to chi-square distribution, but it's a very useful one to be able to apply. And so, we're going to begin from the normal distribution. We're also going to use F distribution as we advance our knowledge. And the F distribution is not difficult to understand. It is not difficult to use. So relax, and you're going to find out that you will be ahead of many people in the future. So what I want you to do for this week, for yourself, is to go and calculate the average and the standard deviation of the data set that I have. Put that in your mind. Go and redo the first homework assignment. If you redo the first homework assignment and do it properly, just let me know. I will open it for you and improve your score. Okay, that is what you need to do. And I want to see you use the formula. I don't want you to go and copy what I just did and then say you have it. No, you don't have it. I'm going to see you. I'm going to check for the formula to make sure that you use the formula from Excel to calculate the averages. Now, so for this class, for this module, to understand the probability distribution, like I said, we're not going to learn how to do the uniform distribution. And so we're going to describe the normal distribution, how to calculate it. Okay, we're not going to do binomial distribution. So I'm going to rule those out. Okay, we're not going to do exponential. So what's going to happen? Okay, we're not going to do the uniform distribution. Right. Right. So this class, gonna take that off. Take that off. All right. So we're going to focus on the normal distribution. All right. So I'm going to repost this for this class. So the question then becomes, what is the normal distribution? Okay. We're going to talk about it very, very briefly and allow you to digest it. Okay. Like I said, the normal distribution is a bell-shaped distribution. This is what they call a bell-shaped. Okay. So a bell-shaped distribution. Now, what it is, and before we talk about the bell shape and what have you, is that, okay, characteristics, normal distribution, okay, is a special member, said before, okay, as an special member in the sense that is hypothetical. Okay. It's called Z, Z distribution. It has a mean equals 0. Okay. And the mean, going to insert symbol I don't know why this. Okay. Mean Oh, sorry. The mean mu equals 0. It has standard deviation sigma. See if I can find sigma here. Let's see. Mathematical. Sigma equals 1. So this is a hypothetical value called Z, which has a population mean mu or 0 and a standard deviation equals 1. Now, like it was said here, the next stage is symmetrically distributed. And so the mean value 0 falls squarely in the middle here. And it has a standard deviation 1, such that one step to the right is equal to one step to the left. Now, the other thing about it then is that symmetrical distribution has area equals 1. Okay. Symmetrical, I couldn't spell symmetrical, has an area equals 1. And so each half or each side of the distribution has area equals 0.5. Say 0.5. Okay. And so if you look at this, consists divided exactly in the middle. The right side has an area equals half. The left side has an area equals half. And so if you go one step to the right, let's see. Okay, that's not a good illustration, and I'm going to take it out so it doesn't confuse people. Okay. If you go one step to the right, the area from 0, from this middle to one step to the right, is exactly the same area as if you go from the middle to the left one step. So if you go one standard deviation from 0 to 1, the area under the curve is the same thing as the area under the curve if you go one step to the left, okay? Or one standard deviation to the left. And so as you can see, the normal distribution has an infinite, it continues infinitely from 0 here to plus infinity, from 0 here to minus infinity. So and with that understanding, we are going to be able to do confidence intervals, okay? That is what we're going to do next, but I don't want to rush it, okay? So I'm going to extend your homework assignment so that next week we're going to practice confidence intervals. Don't let me forget that. We're going to practice confidence intervals so that you can do your assignment right. For now, go and redo your first mock assignment. Okay, if you didn't do this. Yes.
Dr. Egby, will
Yes.
the quiz be postponed too? The
Yes,
quiz
everything
for
will be
this week?
postponed. Yes, everything.
Okay.
Okay, but you may end up doing double work, doing the 2 weeks work at the same time because it's going to be an extension. All right.
Okay. Okay.
But I want us to do things right. I want you to come out of this class and out of this degree program and demonstrate that you can do things right. Okay. Don't just go through the steps. Get a C or a C plus and say, hoorah. All right.
Okay.
So I'm looking forward to seeing everybody next week.
Okay.
All right.
Okay.
Does anybody have any special questions for me?
No.
No. All right. I hope so. All right. So I'll see you guys then.
Okay, bye. Have a good night.
Have a good night.
Me too.
Thank you.
Thank you.